Hey everyone, welcome back, and today let's solve Leetcode problem 2364 titled Count Number of Bad Pairs. So we're given a zero-index integer array nums, and a pair of indices ij is a bad pair if I is less than j, that index that is, and j minus I is not equal to nums at j minus nums at I. And we need to simply return the total number of bad pairs in nums. So in example 1, we have our input array nums to be 4133, and our output is 5. The reason why is because we have 5 different or unique pairs of indices that are actually bad, basically meaning that for every index I and j, where I is less than j, the absolute difference, or basically j minus I, is not equal to the difference between the values at those two specific elements respectively. So the 5 pairs that meet that criteria would be first 01, 02, 03, 12, and 23, right? Because for all of these pairs, where I and j are the first zeroth and first values correspondingly or respectively, I is less than j, of course, and nums at j minus nums at I is not equal to j minus I. In example 2, we have our input array nums to be 1, 2, 3, 4, 5, and in this case, there are actually no bad pairs because we know that j minus I should not be equal to nums at j minus nums at I. And there isn't a single pair of indices that meets that criteria or that is actually considered to be bad. And that's why we have an output of 0. So for the constraints here, we see that the length of input array nums is not going to exceed 10 to the 5th power and be at least one element. And we see that the value of any value inside or in the input array is not going to exceed 10 to the 9th power. So let's talk about how we can actually kind of lead to our solution for this problem. Well, a good observation to really make is that instead of actually comparing the differences between indices and values directly, really all we have to do is actually compare the expression that the problem gives us. Now, this expression isn't really like nice to work with or easy to read, so if you use some simple mathematical properties and rewrite this equation by moving some elements on the other side of the equation, or on the right hand side that is, we see that j minus nums at j, should not be equal to, so I don't actually know if that's should not be equal to, is just what I'll say, I minus nums at I. This is basically just me moving around or simplifying this original input equation. I'm not actually changing the true value statement of it. Okay, so we know that this should always determine if a pair is actually bad, and if a pair is bad, this would actually be true. That's kind of on the simplified version what we're really looking at, right? That kind of leads us to that transformation where, again, we don't actually have to check all the indices and values directly, right? All we have to do is actually compare the expressions I minus nums at I and j minus nums at j. And of course, if they aren't equal, we know that that current pair, ij, is considered to be bad. So how is our kind of high-level rundown solution for the approach to this problem really going to look like? Effectively, we're first going to use a hash map or a dictionary in Python, really just to keep track of the frequency of every single I minus nums that I value in the input that we actually find, every single value that is, as we actually iterate through the input. And what really that's going to help us do is basically it's going to count the number of good pairs, and then all we have to do is simply just subtract the total possible pairs to get the total number of bad pairs, because the total number of possible pairs minus the total number of good pairs in the input array, giving us simple math, would give us the total number of bad pairs. So how we're going to work, basically we're going to have a bad pairs variable that's literally just going to store the count of number of bad pairs. We iterate through the input array using an index I, and for each element nums at index I, we simply compute the value I minus nums at I, and if we've seen the value before, that means we simply just increment its value or update its ending index at index I by 1 in that input. Or the number of bad pairs that involves that index I would then be I minus count at I minus nums at I. Right? And effectively, we update that bad pair's value accordingly, or rather count accordingly, and increment the count of I minus nums at index I in the count map. And after we actually process all the elements, we simply return the total number or count of all the bad pairs from our hash map. So let's go ahead and start the code. So what I'm first going to do, like I just talked about, is actually initialize my number of bad pairs. I'm literally just going to call it bad pairs and initialize it to 0. And what this is really doing, basically bad pairs is going to keep track of the total number of bad pairs as we actually encounter them through the input array, right? Now let's actually get our hash map here. I'm just going to initialize it to an empty hash map, and basically it's going to store or map the frequency of every single I minus some z index I value, and with its corresponding frequency, basically the number of times we see it, and that's basically going to be very efficient in actually counting the number of good pairs that we actually have. So now let's actually iterate over the array and build up the hash map and our number of good pairs. So I'm going to actually enumerate through the array because we do care about every single index according or with its specific value as well. So for every single I and num, instead of just looping through, we're going to actually enumerate through the input array, because this also keeps track of the index along with every single number or element in the input array nums, right, where I would be the index and num would be the current element or number, right, basically to actually get both the index and the value in each iteration. Now first we have to actually calculate the difference of the current index I. I'm just literally going to call that difference. It's going to be I minus the current value num, right, basically for each element in this iteration, or for each iteration in this for loop here, we're simply getting the difference between its index and its actual value, right, which is again basically I minus num z I. And that is actually going to help us identify the number of good pairs. Now, what if we've already seen this difference before? Meaning if if it's already in the count, meaning we've already seen this difference before, if it already exists in the count dictionary, we simply have to increment its value accordingly. So we'll get bad pairs, and increment it by I minus count at index diff, because we know that diff is actually a key value or index in the count hash map, right? Basically, if we've actually seen it before, that means that there are actually count at index diff good pairs that end at the current index I, and so the number of bad pairs that involves the current index I would simply be I minus count at diff. And we're incrementing that result, or the number of bad pairs involving this specific index I, to our bad pairs count. But what if the bad pairs does not exist, meaning we haven't actually encountered this difference before, and we can handle that using a simple else conditional? I mean, that means diff is not in the count, it does not actually exist, and if that's the case, we simply increment bad pairs by the current index I itself, right? Because we know that if we haven't seen the difference before, that means that all the previous pairs with index I would be bad. And so we have to add I to the bad pairs count, because all the previous pairs that include index I would then be bad. And effectively in each iteration, we then want to actually update the count dictionary with the current difference element or frequency by 1. So basically count at diff. We've seen it one more time in this iteration, and so we want to increment it by 1. But we're not actually given that this is actually a default dictionary. So in this case, I'll have to actually use the .get method. So in this case, how I'm actually going to do it is basically going to be count.get. I'll pass in as my parameter or initial input the difference, but if that diff isn't a key, I'll have a default value of 0 and increment its value by 1, meaning we've actually seen it or seen this diff one more time, and so we're incrementing the frequency or count of the current diff value by 1. And of course, if the dictionary diff, or rather if the diff difference value is not already in the dictionary, then count.get diff 0 would just output or return a default value of 0, and we'd set it to 1 by adding 1 to it for this current iteration. And then effectively, once we actually finish processing all the elements, we simply have to return the bad pairs, because it would actually store the total count of the bad pairs that we have involving each index I in the entire input array, right? So if I were to submit this, this would actually be submitted, and this would actually be a valid solution. And as you can see, this really is just about as efficient as you can get it to be. So in a high-level rundown, how our solution actually works, basically we iterate through the input array. We actually calculate the difference between each index and its corresponding value for every index in the input array and every iteration of the for loop. And we also use that count dictionary or hash map to actually keep track of how many times each difference has actually occurred with its frequency. And effectively, we're basically efficiently counting using the solution the number of bad pairs without having to actually compare every single possible pair, and that's going to give us a time complexity of big O of n, because if we checked every single possible pair, we'd have to do that using nested loops as the brute force solution, which would be a big O of n squared complexity. And that brings us to the runtime and memory or space complexity. For the runtime complexity, this really is just a one-pass solution. We're traversing the array once, and we're performing constant time operations within each iteration or within the loop, right? Because really we're iterating through each element in the input exactly once with a single for loop. And so the total time complexity is actually going to be linear with respect to the size of the input array, meaning it is big O of n or a linear time solution. And for the memory or space complexity, it's also going to be a big O of n or linear solution, because in the worst case, our count dictionary could store a unique entry or key value pair for every single element in the input array, and that would be scaling linearly with the space usage according to our input array, because we could store a unique entry in the hash map for every single element in the input. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I'll see you guys in the next video. Bye bye.